All right, welcome back. Today we're going to finish Chapter 4, Section 3. We've learned a lot so far. We've done some examples, and I think it might be helpful to keep things straight. You'll be asked several different types of questions based on what we learned in this section, and it'll be important to know what to use for which type of question. So I tried to summarize that here on the left side of my board. So the first type of question would be asking something like, how many possible outcomes are there for whatever series of events this is? This could be rolling a die 3 times. It could be the example using the Potbellies question. That's just where you use the multiplication rule of counting. So if you're rolling a die 3 times, how many different outcomes are there? You just multiply 6 times 6 times 6. Because there are 6 outcomes each time you roll the die, that would be 216. Okay. Different type of question, any question involving probabilities with multiple events. I would recommend making a tree diagram for that. Now the exception would be if you're given a contingency table, that was from a previous section. If you've got that table, you should be able to answer any and or questions based on the table. But the and or questions tend to be different than the ones that involve this event happening, and then another event happening, and then another event happening. If it's a series of events, like the examples that we did the tree diagrams for in this section, those are the only types of questions in this section that ask about probabilities. That is a dead giveaway. Use your tree diagram, show what happens, all the different outcomes for each event, and what the probabilities are. There are 2 other different types of questions in this section that we haven't yet talked about. You might be asked, how many ways are there to put, let's say you've got n objects total. I'm leaving these as variables because it could be any number. Let's say you have n objects and you want to put r out of those n objects in order somehow. And the key here is you're only using some of the objects and the order matters. So we want the order to matter. This is where you're going to use what are called permutations. Permutations. So we're going to leave that last question there for a little bit. We'll come back to that later. But we're going to be talking about permutations here. And permutations are where the order matters. You want to take some of the objects that you've got and put them in a particular order. How many ways can you do that? The formula here for permutations, we're going to denote this P of n comma r. Okay. N is the total number of objects you've got, and r is the number of them that you want to put in order. Usually these two are not going to be the same number. So maybe you've got 15 objects and you want to order 6 of them, let's say. Then n would be 15, r would be 6. Okay. Now, I've already put all of my problems that we're going to be doing here on the board, but before we get to any of them, I'm going to use the space, but it's not having to do with this problem. Okay, just bear with me. Do we all know what this represents? Any idea? I know maybe your instinctive reaction is to say 5, and that you're really excited about it. Well, I mean, that's true. 5 is worth getting excited about. But this is actually mathematical notation. This is what we call a factorial. So that exclamation mark is called a factorial. This is 5 factorial. And the way this is defined, 5 factorial in particular, is that you take whatever number you have factorial and multiply it all the way down to 1. So for example, 5 times 4 times 3 times 2 times 1, that's 20 times 6, that's 120. Okay. So you can find any number factorial by doing this. Chances are, if that number is at all large, you'll want to use a calculator for that. That's okay, right? But the reason I'm introducing you to this factorial notation is the formula for the number of permutations, how many ways you can order objects in a group, involves these factorials. And in fact, if you have n objects and you want to order r of them at a time, the formula here is a fraction. On the top is n factorial. And on the bottom is n minus r factorial. Okay, so n factorial over n minus r factorial. And once you've got numbers there for n and r, it actually becomes a fairly simple calculation. So let me erase my factorial stuff there. And we'll go ahead and look at an example of this in action. So example 1, we've got 10 people that enter a raffle for first, second, and third prize. Right? So you can imagine first prize is best, second prize not quite as much money, third prize even less than second. Okay, so there is a difference between these three. How many ways can the prizes be distributed among those 10 people? Okay, so we're just getting used to this formula here. So I'll go ahead and tell you this is a permutations problem because we've got n objects, we've got 10 people here, and we want to find out how many ways we can order 3 of them. Okay? So in problems like this, what I tend to do first is write out n equals and r equals, and just put what numbers they are. So n is the total number of people. That's going to be 10 here. So n is 10. And r is the number of people that we want to put in order. There are 3 prizes, so that's a 3. N is 10, r is 3. So we want to calculate this. So p of 10, 3 is going to be equal to, we're going to have n factorial on top, so that's 10 factorial, over, this is going to be n minus r, or 10 minus 3. Okay. So this is, I'm just going to go ahead and do this subtraction. You may get the idea that you're supposed to distribute this factorial in here and make this 10 factorial minus 3 factorial. Don't do that. Order of operations would say, deal with parentheses first. Do the subtraction. 10 minus 3 is 7. So this is really 7 factorial on the bottom. Okay. So we just need to calculate what this is. So let's use the idea of a factorial here. I'm just going to write that down here. I'm going to write it out. I'm not always going to do this, but I think you'll be interested to see how this works. So on the top, we're just going to have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yeah, that's a big number. I'm not even sure what that is off the top of my head. But let's now write our denominator. We've got 7 factorial, so that's just going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now, our goal as mathematicians and statisticians is to try and make something like this as easy as possible. See anything we can do with this? We can cancel quite a few things out here, can't we? We've got 7 times 6 times 5 times 4 times 3 times 2 times 1 on the top and the bottom. So we can actually cross out all of this stuff on the top and the bottom. It all cancels out to 1. This is just going to be 10 times 9 times 8. That is 10 times 72. Or 720. 720. So what we're saying is, if there are 10 people entering a raffle for first, second, and third prize, you can find 720 different ways to order the people who get the 3 prizes. Okay? And the reason we're using permutations here is because the order matters. First, second, and third prize are all different. Trust me, you wouldn't want third prize and say that's as good as first. Since these are distinct and they are different, the order of the prizes matters. And so we use this formula, we plug in N and R, a bunch of stuff cancels out, and we get our answer. If you feel relatively comfortable with this, using this formula, I recommend pausing the video for a sec and doing this next example. You can put it right next to the one you just did. Okay, so example 1 and example 2 are going to go right in that note in the notes where it says permutations are counted when. Example 3 is actually problem number 2 on the front side of the notes. So, pause the video, take a look at this one, solve it if you can, and we'll go through it in just a sec. Okay, so one of the things about when you first start, again, I recommend putting in what N and R are equal to before anything else. N is always going to be at least as big as R. So if you've got 2 different numbers in this problem, you can rest assured knowing the bigger one is N. N is always bigger. So this is 31 here, and this is 20. Okay. If you do that backwards, you're going to end up, when you use the formula, getting like a negative number down here in the bottom, and you can't take the factorial of a negative number, at least not when you're dealing with permutations. Okay? So if you don't remember which one's which, and you guess, once you use the formula, if you get a negative number inside here, switch N and R. Okay? Should get a positive number in there. So this time we're looking for the number of permutations. We've got 31 seats here, and we want to organize 20 students. This is a very real problem for teachers. You have to come up with the exact right seating chart for the students in your room. So how many different ways are there that you could do it? That's what this formula will tell us. So this is going to be 31 factorial on top over N minus R is 31 minus 20 factorial. Okay, so that's going to be 31 factorial over 11 factorial. Now, these numbers are a little large. I'll give you that. You could notice, if you wrote it out like this, everything from 11 all the way down to 1 would cancel out on the top and bottom. So this is going to be equal to whatever 31 times 30 times 29 all the way down to times 12 would be. But if you have a calculator like this is a TI-84 Plus, but it should work with like a TI-83, any kind of graphing calculator, or really any calculator that has a factorial button or a factorial option, you can do this very easily. So for those of you that have a TI-83 or 84, if you want to do this, type in your 31, and then go straight to the math key. Math, that's this one right here below the alpha button. Boop. Okay. And you get this list. You don't want this list. You want to go over to Perb here at the top. Perb stands for probability. Boop, boop, boop. And you'll get this. And you are looking for that number 4. Yeah. Factorial. So hit enter there, and you get 31 factorial. So what we want is that divided by 11 factorial. So you can just go ahead and do all that at once. I've got 31 factorial. I'm going to divide by 11 factorial. Okay, just going back to Perb, down to that exclamation point. 31 factorial divided by 11 factorial. And that equals, this is going to be a big number, I think. Okay. 2.06 times 10 to the 26th power. .06 times 10 to the 26th power. Yeah. That is the number of ways to put 20 students in 31 seats, where the order matters. This is a big number. This is a very big number. This is, and I had to look this up, this is 206 septillions, which is 206 billion billions. There are 206 billion ways to organize 20 students in a room of 31 seats where the order matters. And teachers have to find the one way of ordering those 20 students in those 31 seats that is best. That's an argument that teachers are underpaid. I'm just saying. There are a lot of options, and we gotta find the best one. So, the numbers here get pretty silly pretty quickly. Like, you can imagine doing a permutations problem where these numbers are in the hundreds or thousands. This is going to be just an unfathomably big number. But we don't have to come up with what all those different orders are, just how many there are. And even for a number this big, this calculation, not particularly difficult. As long as you understand what a factorial is, and maybe if these numbers are pretty big, knowing how to do it on your calculator. I highly recommend getting a calculator that can do factorials for this. All right, so we are ready for this one. Example number 3, which is number 2 on the front side of the notes, of the 4-3 notes. How many ways can you put 4 different cubes into 8 buckets? Okay, the ordering of the cubes matters because the cubes are all different colors in this problem. I think that's what it says. Okay, so I encourage you, pause the video, see if you can use what we've done in these 2 problems to come up with the answer for this one. So I've gotten it to 8 factorial over 4 factorial here. Using the calculator, I get 1,680. (1,680) ways to put those 4 cubes into 8 buckets. That seems like a lot, but remember, for permutations, for all of these, the order matters. So you could put the 4 cubes into the first 4 of those buckets, but you could do that more than one way, because you could do blue, green, yellow, pink, or blue, yellow, green, pink, or blue, pink, green, yellow, or all the different ways you could do that, and that's just using the first 4 buckets, not all 8. Okay, so if the order of the objects matters, you're using permutations, you're using this formula, and these numbers are probably going to be pretty big, even if your n and r are fairly small. All right. So, what about if your question asks something like this? You've still got n objects, and you still want to mess with r of them at a time, but all you want to do is group those r objects. The order no longer matters. You just want to know how many different groups you can make. Instead of using permutations, because permutations are only if the order matters, if the order doesn't matter and you're just grouping, this is where we're going to use combinations. Okay? Combinations. Okay? So permutations and combinations refer to similar situations. And my mother, bless her soul, she taught high school math for years and years and years and years. And she occasionally taught classes where probability was involved. She found out that I was going to do statistics for my master's degree and then end up teaching statistics, and she's like, oh my gosh, I hate statistics. I'm like, Mom, what? She's like, yeah, those permutations and combinations, I never remember which one's which. And I'm just like, Mom, it's easy. Permutations are what you use if the order matters. If you're just grouping things, it's combinations. She's just got it in her head that she'll never know the difference, and she just refuses to learn. So let me save you decades and decades of statistical anguish and help you get it straight right now. Permutations are where the order matters. Combinations are where they don't. Okay? If it helps, the root of this word permutations is to permute. If you're permuting things, that's just another word for order. When you permute things, you're putting them in order. Okay? Whereas if you're just grouping things together, you're just combining them. Okay? Group, so combine equals group. Okay? Permuting is in order, grouping is just combining. Okay? I want to make those as separate as possible in your mind so that when you see a problem, you know which one to use. Permutations are if the order matters, and you use this formula. Combinations, on the other hand, are when you are just grouping. Just grouping. We're not putting things in order, we're just seeing how many groups we can make. The formula is a little different. We're using C instead of P, obviously, for combinations. But you've still got N and R. Still got N and R. This is still going to be a fraction, and the numerator is the same. The difference is in the denominator. So here you're going to have r factorial times n minus r factorial. So if you compare our two formulas here, the only difference is for combinations, you've got an extra r factorial in the denominator. If we've got something extra down here on the bottom of the fraction, that means the number of combinations for a given number of n and r is going to be smaller than the number of permutations. Let me say that again. Since we've got more stuff in the denominator here, the number of combinations is going to be smaller than the number of permutations for a given value of n and r. You may or may not believe me there. Let's just do some examples here. First example, that's going to go at the bottom there on the back of your notes. 15 people apply for 5 open positions. Okay? These 5 positions are all exactly the same. There's no difference between these positions. There's no order involved. We're just giving 5 people the same job. How many different groups of 5 people can be hired out of those 15? Again, all of the jobs are the same. There's no order involved, so we're not doing permutations here. How many groups of 5 can we make out of 15? Okay, well, we start this problem the same way as we did permutations. We find out what n and r are. And still, if you've got 2 numbers in the problem, n is the bigger number. So n here is going to be the number of people that we've got, 15. And R is how big the groups are. How many jobs are we filling? 5. So N is 15, R is 5. So we're looking for C 15, 5. It's an ugly 5. Okay, so this is going to be 15 factorial over R factorial, R is 5, so this is 5 factorial, times N minus R, 15 minus 5 factorial. Now, some of you are like, Mr. Seplik, you write 15 minus 5 in there. You know that's 10, right? Yes, I'm aware that 15 minus 5 is 10. I do still write that step, even when I'm doing these problems on my own, because I don't know, I'm just, I'm super scared that if I just do that step right away in my head, that I'm going to mess something up. I don't know what exactly I would mess up, but I'm not willing to take that chance. I want to get things right. It's important. I'm making videos and I'm putting them on the internet. So I'm going to write out this step so I don't screw up. All right? Because mess ups on the internet are forever. So now I'm just going to rewrite that with the 10 in there. Okay. So here, I will go ahead and put that in my calculator exactly as I see it there. And you're going to have to be careful here. I've got 15 factorial. Okay, you type that in just like you did before. You got your 15, and then you go to math, and then over to perb number 4 to get that factorial button. And I'm going to divide by these two things multiplied together, 5 factorial and 10 factorial. Before you type that 5, you're going to want to type a parentheses. Okay. Otherwise, your calculator is going to follow the order of operations and do 15 factorial divided by 5 factorial, and then take its answer and multiply it by 10 factorial. You don't want that. You want to divide by 10 factorial as well. So we're going to do this, put our 5 factorial in there, and then put the 10 factorial right next to it. Like that. Close your parentheses. Enter. 3003. 3003. So if we've got 15 people applying for 5 open positions, there are 3,003 different groups of 5 people that we can hire. Now, for an additional exercise, what you could do, take n equals 15 and r equals 5 and put it into the permutations formula and see what you get. I'm telling you that number is going to be way higher than 3003 because you're not dividing by 5 factorial. Okay, so that's one combinations problem. If you feel good, I recommend example 2, which goes right next to example 1 in your notes. Go ahead, try this one out. Pause the video, try it out. So setting this up here, we've got 26 factorial, because n is 26 here, over 20 factorial times 26 minus 20 factorial. Okay. So this is 26 factorial over 20 factorial 6 factorial. Okay, we can put that in our calculator as well. 26 factorial divided by, in parentheses, 20 factorial times 6 factorial. Okay. So again, if you're going to use a graphing calculator like this, you should type it in like this. That gives you, oh my, 230,230. That's how many different 20 question tests can be made from a bank of 26 questions if the order of the questions doesn't matter. Okay? If you've got two tests that have the same 20 questions but in different orders, they're the same test. Okay? So assuming that that's the case, that the order doesn't matter, there are over 230,000 different 20 question tests if you've got a bank of 26 questions. So again, teachers, maybe we have a bank of 26 questions, want to make a 20 question test. There are over 230,000 different tests we can make. We gotta find the right one that tests what you guys know. Just saying, it's tough. It's tough. All right. So, one more example using combinations here. Number 3 on the front. How many different collections of 5 items can you buy from a selection of 12 items? Okay, so maybe you're at Kroger, you've got 12 things sitting on the shelf, and you want to buy 5 of them. How many different groups of 5 items could you get from those 12? This is a combinations problem again, because it doesn't matter what order you buy the 5 items in. It just matters which 5 you grab. Okay. So if this were a permutations problem, we would have to say something like, how many different ways can you order the 5 items? Or something like that. Okay, but if all that matters is that you get 5 items, we're just grouping here, not ordering, that's combinations. So, give it a shot if you haven't already. You can pause the video. Trust me, I'll wait. I'm a very patient person. N is 12, R is 5. So we want the number of combinations for 12 and 5. N factorial on top, that's 12 factorial. Now on the bottom we've got R factorial, that's 5 factorial, times N minus R is 12 minus 5 factorial. So that's 12 over 5, 7. Okay, we're going to type that in same way we always do. Yep. $792. 792 different combinations of 5 items out of 12. Perfect. All right, so hopefully this helps you out as you work on your 4-3 homework assignment. You'll get some problems. I don't remember off the top of my head if they tell you what to use or not. If it does, great. But if not, take what type of problem it is, what it's asking you, and figure out how you need to tackle it. Okay, whether it's the multiplication rule of counting, whether you should make a tree diagram if there are probabilities involved, permutations if there's order involved, or combinations if not. Okay. Hopefully this helps. It was a little bit longer of a video than I would have liked, but we jam-packed it with a bunch of examples to try and help out as much as possible. So as you work through the homework questions on your next e-learning day, keep in mind that I am still available. If you're the type of student who would raise their hand in class if they had a question working on their homework, you should be able to raise your hand by shooting me a quick email or remind text. Okay, I want to be accessible to you guys. Some people have already done this, and I think that they're glad that they did. Okay, I will not bite your head off. I will not call you stupid. I appreciate being able to help my students. And in situations like this, I really, really want you to reach out if that's something you think you should be doing. Don't let anything stop you. Right? It's a good thing to learn to do, especially if you're going to go to college in the future. If you get stuck in a class, go to your professor's office hours. Maybe they'll think you're stupid because they're a terrible person, but if you get a good grade in the class as a result, I think that's a smart thing to do. So I'm just saying, if you got questions, let me know. For sure, Wednesday through Friday, from 9 a.m. to 12, I'm sitting in front of my computer because I have to, and I will instantly answer your question. Any other days or any other times outside of those hours, I will get to your question as soon as I can. Okay, you've got my word. I am here to help you all. I want to make sure that you're getting this stuff. This is hard. This can be hard. So anyway, that's it for this video. It's gone long enough. We'll see you for the Chapter 4 review. I'll make a short video about that, but I'll give you a list of what you need to know so you can study, and you'll be taking your Chapter 4 test here in a few e-learning days. So be prepared for that. So have a great day, and we'll see you all next time.